For centuries, humanity has never ceased to push the boundaries of its understanding of the world. From the discovery of electricity to the exploration of space, each scientific breakthrough has reshaped our societies. Right now, a new revolution is taking shape: quantum computing. At the crossroads of quantum physics and computer science, this still nascent field is already generating huge excitement. But what is quantum computing, and why is everyone talking about it? Welcome to ZapTech. Today, we're going to explore the infinitely small. Before we head off on a new adventure, don't forget to like the video and subscribe to the channel so you don't miss a thing. To understand quantum computing, we first need to go back to the end of the 19th century, when traditional physics began to show its limitations. Scientists like Max Planck and Albert Einstein discovered that in the realm of the infinitely small, ordinary rules no longer apply. They observed strange phenomena, particles capable of being in multiple states at once or interacting instantaneously despite distance, something Einstein called spooky. Quantum computing makes use of precisely these puzzling phenomena, such as superposition and entanglement. Superposition is the ability of quantum bits, known as qubits, to take on multiple values at once. In a classical computer, a bit is either 0 or 1. In a quantum computer, a qubit can be 0 and 1 simultaneously, drastically multiplying potential computing power. Entanglement is the phenomenon by which two particles remain connected, so that by knowing the state of one, you instantly know the state of the other. Applied to computing, entanglement allows qubits to cooperate in an exponential manner, paving the way for parallel calculations on an unprecedented scale. In theory, all this points to solving complex problems faster than any classical supercomputer. In recent years, several tech giants have engaged in a real race for quantum power. Google made a splash in 2019 by announcing it had achieved quantum supremacy with its 53-qubit Sycamore processor, capable of performing in a few minutes a calculation that, according to Google, would take a classical supercomputer thousands of years to complete. IBM, for its part, developed the IBM Quantum Platform, accessible via the cloud to the public and researchers alike. This initiative allows anyone, from the casual enthusiast to the expert, to run experiments on real quantum computers online. Other companies and startups, such as D-Wave, IonQ, or Rigetti, also offer machines operating on quantum principles. Each of these approaches has its own advantages and challenges, be it qubit stability or error correction. To date, we still don't know which technology will end up dominating, but the competition is fierce and innovation is moving at a rapid pace. Beyond the scientific feat, quantum computing could have a major impact in many fields of cryptography. Classical encryption methods like RSA rely on the difficulty of factoring large numbers. A sufficiently powerful quantum computer could break these codes in record time. Governments and large companies therefore fear a complete upheaval of current computer security. To prepare, new so-called post-quantum algorithms are already being developed. Artificial intelligence. Machine learning could make a dramatic leap forward. Quantum algorithms promise to analyze massive databases much more quickly, speeding up the creation of ever more efficient AI. Medicine. The design of new drugs or new molecules often relies on extremely complex simulations. Thanks to quantum computers, it would become possible to simulate the behavior of molecules much more precisely, paving the way for targeted and more effective treatments. From banking to logistics, chemistry to aerospace, every sector could benefit from these advances. However, there is still a long way to go before we have fully operational large-scale quantum computers. Qubits are extremely fragile and sensitive to their environment. The slightest disturbance, such as a change in temperature or a slight magnetic field, can cause decoherence and ruin a calculation. That's why most experimental machines operate at temperatures close to absolute zero. Another major challenge lies in error correction. Unlike classical bits, the smallest quantum fluctuation can introduce errors into the system. Researchers are competing in ingenuity to create more robust qubits and correction protocols capable of compensating for these errors. Are we really on the verge of a revolution? Many think so. Although technical obstacles remain, each year brings its share of progress. Collaboration between researchers, companies, and governments is intensifying. In the coming decades, it seems plausible that stable and sufficiently powerful quantum computers will emerge to shake up our methods of calculation. In this perspective, training the next generation of engineers, scientists, and developers is essential, as they will be the architects of this quantum future. Quantum computing is a journey into a domain where our intuition is constantly challenged. It represents the frontier of what is possible in computation and scientific exploration. So, are we at the dawn of a revolution? Probably, but its full realization will still take time and a lot of effort. What is certain is that the promise of quantum computing has never been closer to becoming reality. And if history has taught us anything, it's that major scientific discoveries always end up surprising us, sometimes beyond what we could have imagined.